It's okay, we'll just skip this video. It's on YouTube, you can see the video. It was his start season. But anyway, okay, so during this presentation, I'll talk about the team and the project we are working on and the technical challenges we face. And once it's done, we'll see the technical solution we choose to develop. Then I'll continue by showing you all the Mighty Bridge works and what type of tools we can do with it. But first, brief introduction. I'm Valentin Caille, and I'm a senior technical artist at Montreal Cloud Empire Game. I've been in the game industry for 10 years. Before that, I used to work at Ubisoft Montreal, and I'm focusing on creating procedural tools, and mostly with Houdini. And everything you'll see is teamwork, so I also want to introduce the Montreal tool team, created 3 years ago by 3 persons, including me. We based at Turbulent Montreal studio, but now we are a team of 9 persons, 4 technical artists, 4 programmers, and 1 dev QA. But we're also working with other team, technical artists across the world, across the different CIG studios, Austin, Manchester, and Frankfurt. Okay, so start season. It's a very ambitious project. It's with tons of technical challenges. In-game, the framework works fine, okay? It's not the in-game framework. Sorry, terrible presentation. Sorry about that. But you can interpolate the frame in your mind if you want. So, no, but the video is too heavy. It's my fault. So, Star Season, it's a massive multiplayer game that plans to support a large number of players in the same persistent and living universe with NPCs and creatures everywhere, with a dynamic economic system. And for this, we are implementing our server meshing technology to maintain a stable network connection to synchronize the action of potentially thousands of players simultaneously. The scale of the game is outsized. At the end, we probably have thousands of planets to explore, like this one, with a large number of locations scattered on it, like cities, villages, caves, crash sites, underground facilities. Into space, we also have a huge, fully explorable space station, asteroid field, and cosmic gas cloud, and all of this with a very high level of details. You can travel from space to ground without any loading screen. We have runtime procedural generation, mostly for planets, but we also have baked procedural and mostly for location. And in these environments, you can seamlessly transitioning between various type of gameplay elements, spaceflight, exploration, FPS combat, mining, racing, trading, building. You can do it as solo player or with a teammate. All of this is an open alpha. We have an iterative development process. We constantly add new content and experimentation, gathering feedbacks and implementing changes while maintaining stability and balance. And the last shot, yeah. And the destruction is Houdini. Okay, so now we know the scope of the project and the technical challenges. It becomes obvious we need to be able to have an impact of any team who works on the project. Helping artists by generate geometry or placing objects is one thing, but we need to be able to do more, to be able to automatically create complex setup for mission, for vehicle, for AI, navigation, audio, and to be able to debug this easily. To help efficiently, we need to get and set any type of information from Houdini and use the procedural workflow of Houdini. So for that, we choose microservices. So to be able to call simple commands directly from Houdini to the star engine, so the game editor, and to get a result if needed. For the technical details, we use protobuf to serialize the data, and the transfer is with gRPC framework. So just keep in mind that workflow is optimized when you want to transfer data from a software to another. So the communication, the bridge is super fast. Okay, let's see a concrete case. So if you want to use a service in Houdini, we start with a Python node where you just import the multi-bridge Python libraries. Then you can create a command object, so a protobuf object. Here we use a getSelectedObject command to get the selection from the editor to Houdini. And you use this object inside the send command function. And to execute it, you just have to cook your graph. And if we take a look to the result, we have a list of objects composed by their GUID, type, name, and transform, so position, rotation, scale. And we can now convert all this data into geometry, so points and attributes. You can see we have a GUID attribute, name, type, and the transform attribute. And all of this is saved as HDA, so it's a utility node that you can reuse into your tools. Okay, so once we have this simple service ready to use in Houdini, you can link another service that can use previously get information. For instance, we now have a list of objects defined by GUID attribute. We can directly call another service by linking another utility node. You can have, for instance, bounding box or the old geometry for each object or specific properties or spline, shape, collision, any type of information you can get from this object inside the editor. You can have different branches into Houdini that you can merge or you can split into different branches. Here's a simple example. In our editor, we have a layer system. So in Houdini, I use the multi-bridge getSelectedLayer service, and I get a point with a layer GUID attribute that I can link directly to the getObjectInLayer service. And now I have a point for each object in the layer with the base information. So I can use a blast node to keep only the light object by using the type attribute. Then I can use the getProperty service to know the light intensity for each point. And so I have a new intensity attribute with the value for each point that I can use, for example, in a split node to separate light whose intensity is greater than 1, those which are lower. And let's say for those which are greater than 1, we apply a random color directly by using the color node of Houdini. And we'll use this color to apply as light color in the editor. And if we cook inside the editor, we have the result, and we can have the result in runtime. And I can do the same with intensity. I can set it directly in Houdini. And for the other points, I use the set selection service to create a new selection inside the editor. Okay, but now we would like to use a tool directly inside the editor without having to work in Houdini. So basically, let's say you are an artist or a level designer and you just want to use a tool made by a technical artist. So let's go with this simple graph. So we get the selected object, we get the geometry for each of these objects, we keep only the top primitives, we scatter points on the primitive, and for each point we assign a random asset file, a rotation, and at the end we spawn object inside the editor. So we save it as HDA. And once in the editor, you can connect the bridge. So for that, you need to have Houdini open in background. It could be Houdini Engine, Houdini Core, or Houdini FX. I'm using Houdini Core to show you what's happening in background. And you have access all the tool we made with Houdini for multi-bridge. And you can select one and spawn it into your level. It creates a new Houdini tool object, or HTO, that is linked to a node in Houdini. You can see here, each time I spawn a tool, a node is created in background in Houdini with the associated HDA. I can create many of them, and if I remove them, it also removes the node, the associated node. Okay, so now let's spawn our tool and select an object and hit the cook button, and it's simple, trigger a cook for the associated node, and we have the result directly. I can change my selection and cook again. Okay, but we want obviously more options, so we can add parameters. We have the basic one, integer, float, string, color, vector, toggle. We can add more specific from our game editor. For example, we have a tag database, so we can create a tag parameter for our tool. We can also create an object list parameter when we can get the selection directly into a list. And in Houdini, you have a list of GUID. We can set some tooltips and stuff like that. You can also use the hide and disable when conditions from Houdini, and it works in the UI once in the editor. And this one is very useful. It's a callback script. So each time a parameter is it's edited in the editor, that triggers a Python script. And this script can change a parameter value in your tool and trigger a cook. So thanks to that, we can have a button behavior. So you see, with a very simple tool, you can have a complex behavior. We can add feedbacks in your tool. So the obvious one is the progress bar. We have a service for that. You can use it as many set progress bar command as you want in your graph, and you can set the value you want. We obviously have a console log specifically for the Mighty Bridge, where you can send a message from Houdini to the editor. It could be a default message, a warning, an error. You can reference a value directly in the message. Could be an attribute or an expression, for instance, to have the number of points in my input. Oh, yeah, this one is very useful. We have a service to send from Houdini to the editor a message box like this one. Do you want to spawn 15 objects? And in the meantime, the cook is paused in Houdini, waiting for an answer for the user. And this answer is stored as detail attribute that can be linked into a switch node, for example, to impact the behavior of the tool. Okay, so because the function call are on editor side, we can reuse specific editor functions because they make sense only in the editor, or because it's faster to use them instead of the Houdini version. So it's the case here for the first one. You can do recast in Houdini by using the recast node in Houdini, but for that you need to import the geometry as collision. But a game editor has a physics engine inside, so we can simply use a recast from the physics engine of the editor and get only the result of this recast. So the service is to call a recast in the editor and get only the result. And like that, we can have thousands of recasts without having loading the geometry into Houdini. And using a tool, you can have a tool, for instance, that spawn object on geometry without having to load the whole geometry in Houdini. If you pay attention, when I have the light selected, we have the wire effect for the radius, and we have a box here. So we asked, can we get a function to draw our own wire effect? So yes, we can have the debug shape services, and you can draw directly from Houdini to the editor. We have the primitives one, your sphere, box, cylinder, and you can draw a custom line directly in Houdini. You can control the color, you can control the width, so it's super useful in a tool. For instance, this one, it's a simple object spawner, but we use the debug shape to show the surface or the volume where you want to spawn your object. And with the Python script, the callback script, when you change the dimension, it automatically recreates the shape. And in addition to the previous service with the recast, we can have this kind of function, scan tool, I don't know. Planets. Planets are one of the main playgrounds in Star Citizen. Obviously, they are runtime generated, so we cannot access to a baked file and load it in Houdini. But we have enough function to recreate it entirely from the editor to Houdini and to get the color, temperature, humidity, elevation, of course, and other terrain-specific properties. We can get the whole planet, and we can recreate a small portion of the planet with more detail. And in addition to the previous service, you can draw a debug shape on it to debug the cliff, for instance. Okay, camera could be super useful if you want to place the camera in a specific location in the editor during your cook. Or you can get the camera transform from the editor to Houdini. And in addition to that, damn it, if you use a small Python script, you can synchronize the editor camera with the Houdini camera. Sorry about the lag. And again, with planet services, you can get the planet around the camera position. Could be useful if you want to spawn objects on planet surface based on camera position. Okay, this one is super useful as well. You can draw geometry in the editor viewport without export it and re-import it in the editor. You can just send to the editor the raw geometry, and it's super fast to use it. It's super optimized, but it's temporary. But it can be complex too. You can have custom normals, vertex color, UVs, material. So you can use it to improve the iteration in your tool. And once a user is happy with the result, you can call a service to export it as a final engine format. You can access to the console variable, or CVAR, from Houdini again. It can be useful if your tool is in a certain context where you need to, for instance, debug the G-buffers or the albedo, the normal. You can apply gray material or chrome material. You can debug the texel density or vertex color, anything you can access from a CVAR. Extra, I can mention we have a screenshot service. In addition with the set camera service could be super useful. We obviously have services for material to get, set, create new material. And we also use the Perforce integration directly. So we are about to check out, revert, and submit file from Houdini. Okay, let's add a new layer of fun. Houdini tool can spawn Houdini tools. So like this, you can build a hierarchy of tools with parent and children. And from children, you can find the parent, or for the parent, you can have access to all the children. For instance, to trigger a cook for all the children. You can set parameters, because from a tool, you can set parameters to other tool. So basically, you have tools controlling other tools. So in that way, you can have a manager tool. And we also have a cooking list, so a queue to cook the tool one by one. And for instance, here we have the modular location tool. That is a hierarchy of tools. So the main tool spawns the room tool spawn interior overlay, which can spawn secondary items, wall, connector module, etc. So each tool is very simple, but used together, they can compose a a more complex and powerful tool. Okay, let's finish with some example tools. Okay, using the Velum brush and the camera services to sync the camera and the debug meshes, we can have a synchronized tool between Houdini and the editor on runtime to generate clothes. So each frame, I remove the debug mesh and I recreate a new one based on the simulation. We also have the cable generator. For this one, I reused the SideFX Lab cable generator. So the input is just the Mighty Bridge spline services, so I get the spline shape. I also use the get geometry in a certain volume, I think, in a bounding box. And the output is debug meshes or export final mesh service. I've mentioned gas cloud previously, so this is an example of what we can do. I get the selected objects, I get the geometry, and convert it in Houdini as VDB to be exported as gas cloud objects directly in the editor. And a pighead, obviously. This one is a prototype I've recently made. It's for a large scattering location tool on planets. So I'm using the shape services, the planet services, and we have a main tool that spawns smaller tool, and each tool is supposed to generate a location on the planet surface. And the last one, same, it's a prototype to show a kind of physics painter made with pop network in Houdini. So each point, each particle in Houdini becomes an object in the editor or to be updated, transform updated in the editor. So there is nothing physics in the editor, it's everything in Houdini. Okay, so as conclusion, I can say with microservices, we can literally take the control of the editor directly from Houdini to make a lot of things directly with the procedural pipeline of Houdini. So basically, you can use it as visual scripting tool. It's super easy to use. Even with basic Houdini skill, that can be used by artists or designer and make a very specific tool to speed up their workflow. It's super easy to make prototype for more complex tool and maybe in-editor tool just to check some stuff. And it's easy to share to everyone because it's HDF5, you can submit on Perforce. And for the future, we want to improve the flow by using Python script, so to be able to draw shape, for instance, directly in the editor viewports. We are also investigating for an event system, so to be able to detect some event, for example, if your selection changes, to trigger a hook or to change a parameter automatically. Obviously, we keep an eye on machine learning. We are in 2024, so we have to do that. And we also want in the future, forgot to mention, to connect Mighty Bridge with other software. Blender, for instance, to be able to connect Blender to the game editor, or to connect Blender with Houdini. And yeah, I hope you find this interesting. Thank you very much. Yeah. I can take some questions, but keep in mind my English is terrible, so please be nice.
Okay. Questions? Where do I run to? Okay.
Thank you so much for that talk. It's very inspirational. And I'm sure that you actually inspire a lot of other teams to want to do something similar to this. So the question is about how much of the aptly named Mighty Bridge you think is fairly generic or highly dependent on the architecture of Star Engine?
Okay, I'm technical artist. I'm not programmer, but I think it can be easy to convert other editor to the same system. Basically, once you have programmer environment for the editor. You can find a function. For instance, you are in the editor, you click on a button, you can find the function called by this button, and you can just say, okay, I want to create a new service by using this function and to be called directly in the Houdini. So I guess it could be easy to convert to have the same system for other game editor.
Thank you for the talk, super
You're
interesting.
welcome.
So you mentioned that anything that's on these huge, large-scale planets is completely procedural at runtime to save memory space, of course. But there's still instances where you would like to use Houdini. For example, in the end, you showed a prototype, I think, to spawn some medium-scale stuff on the planet.
Yeah.
Could you explain a bit more in what cases you use Houdini on the huge planets and how you manage that?
Yeah, so for the planets, they are runtime generated. So the terrain, the biome, the vegetation, the weather as well, it's runtime generated. It's the planet tech. There are some video on YouTube for that, so it's pretty interesting. But we also want to be able to scatter baked location on it, mostly for mission stuff, because you need to have access to something that is not generated yet. So for now, we are generated with baked location directly on planets, but we hope in the future to be able to scatter on runtime location. But to scatter them with Houdini, we have control. We can edit it. You can find, okay, this is a nice mountain with a nice view, so I want to spawn directly on it without having manipulating option in your runtime tool, and to be sure of what you get. With your tool, with Houdini tool, there is no difference between an object spawned by hand than an object spawned by the tool. So once you finish with your tool, you can edit by hand, you can add more stuff, you can move the spawn object or remove them. It makes no difference. So you can generate a first pass with the tool and edit by hand, or with another tool, for instance.
Okay. Thank you very much.
Thank
That
you.
was a lovely talk.
I also want my picture, so I take just a few seconds.
Want me to make it?
No, it's fine. It's better with a, hey. Thank you very much.